Hello sir, my name is Fabian Parshia George. Today I will be presenting on GNU Parallel for the submission of CC 707 assignment 4. So starting with GNU Parallel, as its name suggests, can be used to build and run commands in parallel. You may run the same command with different arguments, whether they're file names, usernames, host names, or lines read from files. GNU Parallel provides shorthand references to many of the most common operations such as input lines, various portions of the input line, different ways to specify the input source, and so on. So basically, GNU Parallel is a shell tool that can execute jobs in parallel using one or more nodes of a cluster computer. So in order to set up environment for using GNU Parallel, we have to use any special program on a cluster. We need to inform the system where to find this special program. There is a convenient system installed on most cluster computing platforms that allows users to add or remove paths to programs they need. This system is known as the module environment system. There is a set of commands we can use in order to query, load, unload modules. To interact with the module environment system, we can use the module command. In this section, we need to use the GNU Parallel program. To check for its availability, we type module avail parallel. We get this output. We see that there are two versions of the module available in Turing. To load the default module, we type the following: module load parallel. In order to clear all load modules, we try the following. Module purge. To list all loaded modules, we type module list. As seen earlier, we can check if a module is available with module available. Let's check what version of Python are available to us. For that, we need to type module available Python. The output we get is this, the different versions. So in this workshop series, we will need different modules depending on the topic covered. For each workshop, a convenient list of modules to load will be made available to us in the workshop materials. So for an example, let's say we want to analyze emails from February and March 1999 from our email set in parallel. All we have to do is type this command. In this listing, we call the parallel command the spam_analysis.py as program to run. The three colons means that what follows is the list of inputs to run spam_analysis.py with. Following this, we can run for a full year. We say 1999. We run this command. So parallel also has the ability to take arguments from the stdin. The previous listing is equivalent to this command. Specifying the number of processes. To specify the number of processes to launch, we use the ---- jobs option. So we then type this command. So the above listing will start 12 processes of spam_analysis.py and will give each one of them a month from 1999 to work on. Note that we have to have 12 processor cores available for this to work efficiently. Otherwise, the available cores will be shared among the 12 processes. So far, we have only used a single node to run our program in parallel. As mentioned before, it is possible to use parallel to run a program on many compute nodes. In order to do so, we first need to request the nodes in a Slurm script. From within the script, we need to establish the list of allocated nodes for our job to run on. This can be done using slurm command sccontrol as follows. So we type this command sccontrol show slurm underscore job underscore node list. So this will display the list of nodes in the allocation, but we need to have it in file so that we can provide it to parallel. So we will be adding this to a file. In order to do that, we write this command sccontrol show slurm underscore job underscore node list, and then the greater than sign, then job underscore node underscore list. Now that the file job underscore node underscore list will be created and will contain the list of all nodes for the allocation, one name per line. We can use parallel command option --ssh log in file to feed the file to parallel. At this point, we have all we need to start our parallel command. So we will then type this command. So this above listing will launch 6 processes of spam underscore analysis dot py on each of the nodes in job underscore node underscore list. One last thing is needed for our command to be complete. We need to specify a working directory where parallel will transfer file from the remote nodes. The option --workdir, that is working directory, takes care of this for us. So in order to do that, we type this command. So next, the pwd command can be used to return the value of the current directory. This means that all the files created remotely from processes created by parallel will be transferred to the path found as value of pwd. That was all. Thank you for your time and patience.